one of the most important topic in your DBMS, okay, DBMS, IMS. Now, what happens in the normalization? Why we need it? We will discuss each and every aspect of normalization. Okay. So again, the PPT is already being uploaded, so don't worry about that part. So I just want to discuss similar, simple things that why we need normalization and what is the need of normalization and what are the advantages and disadvantages lies with it. Okay, so one thing is that normalization ultimate goal is to convert your tables into only two columns. Okay, so this is an ideal scenario. This is an ideal scenario. We will not move forward to that. Suppose you have one table of 1,000 rows, 1,000 columns. Okay, so what you do, you divide this particular tables into only a column of two columns. Okay, there may be multiple tables, around 500 to 600 tables that will be formed. Okay, so this is the ideal scenario why we do normalization, because when we decompose the tables into only two columns, it will be very easy for us to do many things. Okay, but if you're seeing here, when you go towards this particular part, what will happen is that there may be so many tables in the database. We do not also want that. Okay, so we do not want so many tables, and we do not want a single table also. Okay, so there may be a balance between the two. Okay, the balance will be that if we have 1,000 column, so around 10 to 12 tables will be sufficient for us. That will be the right balance. Rather than making 500 600 tables, it will be beneficial for us. Okay, so now why normalization is actually reducing the redundancy and solving the anomalies in the database. Okay, so now what is the redundancy? What are the other things? I'll just explain you with the help of an example. That will be easy for me as well. Okay, so if you look at it, normalization part is very simple. First of all, okay, so you may already know that. You suggest I'm adding one page. Okay, so suppose the example will be that you are giving a table M, and there is a table department. Okay, so this is again well known example. We have done it so many times. There will be employee ID, employee name, and department ID, and again there will be department ID and department name. Okay, so suppose there are entries something like 1A, 1CS. Okay, so now when I'm saying that what happens when we do not this is a foreign key. What happens that if we tend to form only one table. Okay, suppose I say that rather than using these two tables, I only use one table. So what will happen here? Again, you will create a join, and then you combine this table, and then you extract out the relevant entries. That can also happen, but at the end result will be en did, did again, or you can just, because did is already there, there is no need to write did again, and then there is a dname. Okay, so you're combining these tables. Now what will happen here? 1A1CS. Okay, there will be maybe another employee that again belongs to a CS department. Okay, so if you're seeing here, clearly see here that there is no problem doing that. But suppose if there are 100 employees here, this one CS entry will be repeated 100 times. Okay, so one CS entry will be repeated 100 times. So this is referred to as redundancy, that we do not want. Okay, so if we are doing a separate table, if you are seeing here, there is only one entry in the separate table. If I combine the table, there will be many entries of one CS. That can be avoided by using this. Okay, so first of all, why we do not combine everything into one table? That is the main reason. Okay, so if we combine everything into a single table, there will be so many redundant entries. Okay, first reason is that. Okay, 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 there may be advantages to this approach. There may be disadvantages to this approach is that information retrieval is very easy. Okay, uh, but by doing this there will always be a redundancy, so I do not want that. Okay, so anomalies like insertion, deletion and updation, so these are there will be anomalies or in case of insertion, deletion and updation. Okay, so what will the anomalies look like? So what is anomaly here, what is the meaning of it? Okay. So suppose I'm talking about a insertion anomaly. So because you are doing everything in a single table, so there may be a entry that a particular employee belongs to a CS department. Okay, suppose a particular employee belongs to a CS department. What you do, instead of writing CS here, you accidentally written C or CSC. Okay, CS, instead of CS you have written CSC. Okay, so this particular case can happen in only when you are doing a lot of entries at once. Okay, so if there are separate table that there is only one entry, that is one CS, and you can easily apply a operation of join to obtain this table. But if you are combining everything into a single table, when you are inserting something, this particular thing can happen. So this, oh, we all are human, so when we are entering something there can be a mistake. Okay, so if one entry is different, everything will be different. Because what will happen then, if you want to say that I want to delete the CS department, so all the CS department employee will be deleted instead of this one, because here instead of CS it is written as CSC. Okay, so again one another thing can happen, that you have entered the department ID as 2, that can also happen. So these are referred to as insertion anomalies. When you are doing insertion, then you are not inserting the correct entry, so that can happen because we are doing a lot of entries at once. Okay, this is first thing. Another thing is your deletion anomaly. So what is the case of our deletion anomaly? Suppose I want to delete all the employees, all 100 employees that are belonging to a CS department. Okay, so all the employees that belongs to CS department. Okay, now with this what will happen? What will happen? The CS department is completely deleted. Is completely deleted. There is no entry of a CS department there. It's completely deleted. But what if I want to maintain the entry of a CS department? Suppose I have closed this particular CS department, and instead of a CS department I'm assigning some people to other departments. That can also happen. But I'm only concerned that when you are deleting all the employees that are present in our CS department, just for record purposes, I just do not want to delete the department ID as well as the department name. Okay, so there may be some ways that you can keep this particular thing. How can you keep this particular thing? Is that you have to enter null here, because there will be no employee, there will be no entry. You have to enter null here, and you have to maintain the entry of 1 CS. Okay, so this occurs when you delete something. So anomaly occurs when you delete something or when you perform some action. Okay, so with the help, when I have inserted something, there is an anomaly that I maybe when we are inserting, the insertion or the entry is not correct. When I've deleted something, there is an anomaly. So I've performed the action deletion. There is an anomaly that what if I want to maintain the department entry? So if you want to maintain the department entry, you have to write like this. Again, this is not considered as a, what do you say, because EID is already a primary key. You cannot enter a null here. So there may be so many problems that will occur here. There may be structural constraints that will be violated. There may be integrity constraint that may be violated, and you have to code specific exceptions for a particular table. So I do not want that. Instead, if you have just deleted all the employees that are belonging to the department ID 1, so that will be fine. So the main entry will be retained, that is in this particular table, that is referred to as department table. So that is way more efficient than doing this only in one table. Okay, so keep that in mind. Another thing is your updation. So what do I mean by updation is that when you are updating something, okay. So updating here means is that let me just wait for a second. Okay, so just look for the example of updation in PPT. So an insertion anomaly, deletion anomaly, and updation anomaly. Okay, so what actually is happening here, that you are changing the department name to different department. Okay, so suppose previously it was CSC and now it is CS, only CS. So again, what will happen here, this updation anomaly again will change everything. Okay, so suppose previously it was known as CSE. Previously the table was known as CS. Okay, so in the table only CS entry was there, and you are updating that entry to every CSE entry to CS. Okay, so if there is any kind of a different entry that you have created, that was not supposed to happen. Okay, so rather than every entry here, if you're seeing here that uh, all the entries here are changed to CS, sorry, when we are changing CSE to CS, what is happening here, all the entries here that is changed to CS, but only one entry here that does not change to CS. Okay, so this particular thing can happen here because we are seeing here DID is of one of this and DID of one of this CSC. Okay, again DID of one, this is due to insertion anomaly. So when you are inserting something, this particular things can happen. Okay, so because they are how can you update, you update that wherever the DID is 1, you should update it into CS. Okay, so you may be updating it in differently. Okay, so I'll give you another example in the next lecture. Okay, so this is all the anomalies that are related to normalization. Any doubt till now? Okay. So I'll discuss the normalization process of normalization in the next one. Any doubt, you are welcome to ask the question. Otherwise, you can